So when you open RStudio, you may see there are 4 windows. So initially it might look like this. So if you click here, you'll see the 4th one, and this is the area where we type a code, and then below that you have console where you get the output. So in R we can write any comment or remark using hash symbol. So let's say we want to do some calculation, 5 plus 9. So suppose this is the code you want to run and you want to get an answer. We click on run, and in the console area you see you get answer. Something that you want to do quickly, you can directly type into console. For example, if I want to do 15 divided by 3 and hit enter, we can get answer there directly. In R we can define data and data vectors very easily. If you want to assign a data value to a variable called grade, so we can type grade and then a symbol which is pointing towards the grade. So let's say if we want to assign a grade of 90 to this variable called grade and then run this. If you type grade and run, so you'll see that it has taken value of 90. But if you want to assign more than one data points to this grade and create what is called data vector, it's like a variable. So the format is something like this. I have assigned 5 values to the variable grade, and if you run this and run this grade line again, you get the output. You can either select the whole line and then click on run, or you can be anywhere in this line and click on the run. It will work. One thing you may notice is when you run this line, this cursor automatically moves to the next line. So we don't have to really click on the next line to run the next line. If I simply start from here and keep on clicking run, so it will keep on running those commands. Similarly, I can define another variable, let's say name. So note that when we assign data points to text variable like this one, we have to put each value within quotes. So if you run this and then run this name, you can see you get the output. So now name has assumed all these 5 values. One important thing to notice is that R is case sensitive. For example, instead of lowercase n, if I use capital N and try to run that, it will give some error. It says object name not found. So make sure that you use the correct case all the time. So data frame is something like a CSV or Excel file where you have rows and columns. So let's create a data frame with these 2 variables, grade and name. And I'm going to name this data frame my data. We can use any name we like. So in this data frame, we want to use 2 vectors that we have created just now. So now if you type my data, so you can see that it has 2 columns and 5 rows. So DIM is to look at the dimension of whatever data set we have. So for example, this one says that my data has 5 rows and 2 columns. If you want to look at structure of the data, you can say str my data, and it says that my data is a data frame with 5 observations and 2 variables. First variable, which is grade, is numeric and some of the initial values are given here. And similarly, second variable name is a factor or a categorical variable, and some names are given at the beginning. We can also use something called summary that summarizes data set. So you can see it provides a 6 number summary. It gives minimum and then first quartile, median, mean, third quartile and maximum. So 6 numerical summary values. To get information about working directory, we can use command get wd for working directory and open and close parenthesis. It says that right now I'm in this directory. We can also set our own working directory, set working directory, and then we have to give the path within the quotes. So note that this is a working directory on my computer, so you may have something different. So make sure you use the proper one. And suppose I want to set my working directory to desktop of this computer. So I can say desktop and run this line. So now if you check get working directory, you'll see that it has been set to my desktop. So any file that I save will be saved on the desktop. So let's create a file or write a file using write.csv. So note that CSV files are best to use with R. Even if you have Excel file, it is better to convert them into CSV file. We'll save my data that we created just now with 2 columns, grades and names. Let's say we want to name this file as myfile.csv. Once we run this line, and when you go to the desktop, so remember we have set working directory to be our desktop. So we do not have to really specify that path again and again. So now if we go to desktop, you'll see that file is saved. So here is the file that was created just now. If you want to open it, you can double click. You can see this is the file we have. Let's say I want to call first column as ID, and let's add some numbers. So now we can save this file and quit and go back to RStudio. So to read the CSV file, we have to use read.csv, and then we can say what file we want to read. So name of the file is myfile.csv. We do not have to specify path, as you know. In that file, remember in the first row we have all the titles or headers. So while reading it, we have to tell R that the first row should be treated as titles or header. You can say header equals, so remember header is all lowercase and true is all uppercase. Now before I run this line, what I'm going to do is I want to save this file in some variable name. So let's call that as data. The entire content of the file will be read into data. So as soon as we ran that, you can see that data has 7 observations with 3 variables. So if you want to look at the structure of the file, you can do str data. So now it says this is a data frame that has 7 observations and 3 variables. So third variable now is the ID, that was the first column, and second column is grade, third column is name. You can also read a CSV file into R by clicking on import dataset that you see. So if you click there, you may specify that this is from CSV. If you are doing this for the first time, you may have to install this feature, which will be done automatically. So since in this case I already have it, I'm going to say browse and then go to my desktop and click on myfile.csv and then say import, and that file gets imported. So there are more than one ways to import a CSV file into R. R has a lot of data inbuilt, and if you want to see what data is available in R, you can type data and open and close parentheses and run that line. So it gives you a list of all the data sets that are available with the base package. If you want to look at any specific data, for example iris, to use that data we can say data iris. So if you run this line, now that data will be available to us. So we can look at the structure of the data by doing str. This is a bigger data. It has 150 observations with 5 variables. Out of 5 variables, 1, 2, 3, 4 are numeric, and the last one, species, is a factor or categorical variable that has only 3 levels. If you want to look at summary, so if you run that line, it gives you summary of all the variables. So for numeric variables, you can see it's a 6-number summary, but for categorical variables, it looks at how many categories are there and then reports what is the frequency. So for example, first species has 50 data points, second one has 50, and third species also has 50 data points. If you want to look at first few rows of the data set, because sometimes data could be very huge, so you don't want to bring all the data on your screen, but you just want to look at first few lines, you can say head iris. It brings first 6 rows of the data set and shows that on the screen. If you want to look at last 6, you can say tail, and that will give you last 6 out of 150. Let's say you want a different number. With the square bracket, you can specify that, okay, I want only first 3 rows, and let's say I want out of all the columns only 2 columns. So if we run this, you can see you have first 3 rows and first 2 columns from the data set. Or you may leave column area blank. So after comma, if you do not have anything, that means everything. So all the columns. So if we run this, you get first 3 rows and all the columns. This allows you to look at the data in whatever way you want to look at. We want to create a table for variable species. So our data set is iris, and to specify one particular variable, we put a $sign, double click species or type species. So you can do it both ways. And let's save this table in tab. So let's run this line. You see now you have a table for each species. It gives you frequency 50 each. So to make a bar plot, we need to use tab that we created just now. And I'm also going to create some space here. So once you run this, you see there is a bar plot. So this bar plot is plotted with default settings. We can always improve upon the default plot. So let's do that here. You can do it by adding features after comma. To keep things clean, I'm going to hit enter to go to the next line. And let's give a main title using main. So if we run this line, you see now the bar plot has a title. Similarly, we can add few more features. We can give a label to x-axis. So xlab equals. So you can see now we have labeling for x and y axis. If you do not like default color, we can say color equals. So within quotes, if you like blue, you can say blue. Or if you want to make it more colorful, then you can borrow colors from rainbow. And because there are 3 bars, we can say 3. So you have 3 different colors. If you want to see what other attributes or features you can add to the graph, you can type question and then say bar plot. So in the 4th window, you will find a lot of help with any command. So you can see what is the format and what features you can use or what arguments you can use in this command. So it gives you a lot of information. If you go towards the end, it also gives you a lot of examples. We'll make use of the tab where we have the table information for pie chart also. So again, this is by default. You can add things just like we have done earlier. So remember, we have 4 quantitative variables. Suppose you want to do it for sepal length. So we have to specify our data set iris, and with $sign we specify a variable and then run this. So this gives us a histogram, and we can improve upon the histogram just like we have done earlier. You can also make use of breaks to increase or decrease the number of bars. So suppose I specify 15, so we'll see it will have more bars. You can also provide a limit to x-axis from 3 to 9. So x-axis has a limit now from 3 to 9. Or if I want to use 4 to 8, I can say 4 to 8. So it can be customized depending on the data and the situation. So suppose we want a scatter plot between these 2 variables, so we can get that easily. and this tells us whether or not two variables are related to each other. And you can modify or improve upon a graph just like what we had done earlier. You can give a name or you can change a color. So this gives us all possible pairs. So for example, sepal length versus sepal width, this is the plot. Petal length versus petal width, so this plot shows a positive pattern. Similarly, petal width versus sepal length also seems to be a positive pattern, but this one clearly has greater strength. Relation between the two variables is much stronger here compared to this one. One disadvantage here is that there is a repetition. So basically, upper triangle is a mirror image of lower triangle. So this graph versus this graph, we don't gain anything new. R has several packages, and one of them that is used using a library, and we want to call psych. So this is a psychology related package. If you are using for the first time, so you have to go to packages and click on install and type the package you want to install. So psych, you can see it is here, and then click on install, and it may take few seconds and it will be done. So then you need to run the library. So we get a warning message. It says that the package was built under 3.3.2. If it is an error message, then it's a problem, but warning messages are okay. So this gives us this graph here, and you can say this is much more informative than the previous one. So now in the upper triangle, it also gives you correlation coefficient, and a value which is close to +1, that indicates very strong positive correlation. A value which is close to -1, that will indicate strong negative correlation between two variables. And a value which is close to 0, so that indicates there is hardly any correlation between the two variables. And here it also plots a histogram for each variable. So you can see you get much more informative graph in just. So let's read a vehicle failure data file that I have on my desktop. So we can see get working directory. So since our working directory is desktop still, so we don't have to really specify all the details. We can say, so this is the file that I have on my desktop, and it is a vehicle where V is capital, F is capital, and D is capital. While reading this file, what might happen is if you download the same file many times, so it may be called vehicle failure data, and then you may have something like this within parenthesis 1 and then .csv. I would suggest whenever you have such a name where you have 1 or 2 or 3 within parentheses, because file was downloaded many times, so rename this where you delete all this unnecessary within parenthesis numbers. So have the clean name as vehicle failure data.csv, and then read this file into RStudio. So I'm using exact same case. So if it is uppercase, it has to be uppercase, otherwise we get error. And in this data set, I have a header. So each column has a title. So I'm going to say true, and I'm going to read this file into my data, which is a shorter name compared to vehicle failure data. Let's run this. We don't need the quotes. That's why we got error. So remember last time when we did not use quotes. So we have to do the same thing. So now that file has been read. So if you want to look at the structure, my data. So it has several variables like vehicle number. So this is integer variable 1, 2, 3, 4. And then we have FM, which is failure month. 0 means this car failed even before completing first month. Second car failed after 10 months and so on. Then you have mileage at failure and labor hours. So first car repair took 1.1 hour, labor cost. So labor cost for the first repair was $66.30. Material cost. So materials that were replaced on the car. So first one was $697. And then the state is a factor variable. So you have 51. So one of them is star, means that's a missing data. If you want to do summary, so all the variables are summarized the way we have seen earlier. Similarly, if you want to look at head, it gives you first 6 rows of the data set. Now suppose you want to do a pie chart. Let's create a tab the way we have done earlier by using a table for my data and state. Now if you try pie tab, so we run this line, and you can see because there are so many states, this picture is not really very clear. So if you want to only plot some top states, so you will have to select a part of the data from this tab. You see there are many states with just 1 or 4 failures, and there are some states with more than 100 failures. If you want to look at this in a sorted manner, you can say sort tab and run that line and look at tab again. So you'll see that initially it was in alphabetical order A, B, C, D. Now it is in numeric order. So suppose we want to use only 1, 2, 3, 4, 5 top 5 states which have more than 50 failures. We can customize that very easily. So within tab, if you want to specify something, you can use a square bracket and say only those where tab is more than 50. So run that, and again if you want to look at the tab, now we have only 5 states. So now if you do the pie plot, so it looks much better. So here we have only 5 states on the pie chart, but when the number of states increase, that is going to make this look a bit complicated. For example, you have seen if we want to do all 50 states, it looks very crowded. Suppose instead of more than 50, if we have more than 10 and we try to make a pie chart, so again you have too many categories for some of the states. Even if you do more than 20, still you see things are a bit crowded. When we have many categories, a better plot is obviously a bar plot. And as we have done earlier, we can specify various colors to make it stand out. The only thing is not every state is very clearly visible here. We may have to make these labels smaller in size. To do that, you may have to play with some of the attributes related to bar plot. Question mark and bar plot, hit enter. So this will give you more details about how to use these bar plots. So for example, somewhere here it says cex.names equals 1.5. We can change size of x-axis names by using this option. So let's say we want it to be 1. If you zoom it, so this is what we have, no change. And if I reduce this to 0.5, you can see the size goes down. And if you look at the complete chart, now you see names for each state also appear at the bottom. If you want to copy or save any of these plots, you can save image, you can save as a PDF, or you can copy to the clipboard and paste it in Word file or PowerPoint file very easily. If you want to save all this, so you can save this as we save any Word or Excel file. So you can go to File and click on Save As. And suppose we want to name this as Intro. This is being saved on the desktop. So click Save. And now if you close this, intro.r. So this is the file that is saved. So next time when you open RStudio, generally that file will be there automatically, or you can go to File and Open File and locate your file on the desktop and click Open.